What's up, guys? Weather Geek here, bringing you guys a weather update video, and I'm officially making my transition to YouTube. I'm not giving up Twitter at all. I'm just doing this because I can't really expand my thoughts on certain things with Twitter because of the character limit, and just it just gets kind of ridiculous with the threads. I love doing threads, don't get me wrong, but I feel like a video will just help clear up what my thoughts are on certain events. This might be snowstorms, severe thunderstorms, heavy rain, flooding events. And just to give you guys context, I mainly forecast for central Illinois, northern Illinois. That's mainly what I forecast for. All forecast gives it for the Ohio Valley. We're in the Ohio Valley. But I'm just mainly this type of guy. I live in central Illinois, so I'll forecast for Chicago area. I'll forecast for, the I-74 corridor, and I'll forecast, for areas. But like if you're in southern Illinois, I mainly won't forecast for you guys. So basically, what's going on right now? It's 27 degrees. We have about an east wind at about 10 knots in Bloomington. And what's happening is that we have a cold Canadian high pressure system filtering down cold air. So it's 27 degrees right now with a 23 degree dew point. That's pretty, 27 over 23. That's pretty humid, So you would expect probably, possibly some precipitation coming. And indeed, we do have precipitation coming. Let's look at the NAM, I guess, Why not? Because it's a NAM, even though it showed like zero point 0.8 inches of QPF the other day. That ain't gonna happen. It's definitely backed off. But you can see what happens is that we have precipitation moving in tomorrow afternoon. It will be pretty much all snow, I think, for the I-74 corridor. I don't really think it's gonna make some rain. There are like models showing rain, like the but it's definitely warm, and I've seen it in different storms that it's just way too warm with its setup. It just showed all rain in one storm, and that definitely wasn't the case. All models are in disagreement, so you gotta throw it out, just like the NAM did for the other day, showing 0.8 inches of QPF. But basically, snow moves in tomorrow afternoon. It'll be light, for like, several hours. Maybe a few times it'll be moderate, but also it's falling during the day with the Mars sun angle. You get more solar radiation, and then it's going to keep basically like, keep accumulations down. It's going to be harder for it to accumulate. I don't really think there'll be issues on the roads because during the day, unlike last storm, I don't really see a big, 700 millibar from the Genesis driven snow band. I don't see that on models. They were hinting at it, but they just got flat out wrong. I got 5 inches instead of 1 to 2 by, some other sources. I was calling for about 2 to 3 inches, but I got 5 inches instead. But I expect probably about 1 to 2 inches from the storm. People might get coatings, people might get an inch, people might get 2 inches. Just depends on where like the heavier snow sets up, and heavier rates will overcome the March sun. But I don't really see that. Now, if we launch like a sounding, let's say over, Bloomington, let's just say that, okay. And what we see here is that we have a kind of, we definitely have all areas below freezing. We have these dendritic growth zone. It's in a decent amount of omega. These are these dashed lines right here. We have a decent amount of omega, which is basically lift. If you have lift in the dendritic growth zone, you get a lot of snowflakes to form. And if you also have, steep lapse rates, then you can also get, really a lot of snowflake production. And, your ratios are determined there, but, also it's determined by your surface temperatures, and we have about 32 degrees, so it's going to be, on the edge. We won't have the best ratios, we won't have the worst ratios, I've ever seen, but we do have the potential for some accumulating snow tomorrow. Now, basically, why is it going to be snowing? Like we have precipitation, but why is it going to be cold enough? Because as said, we have a Canadian high pressure and filter in colder air from Canada. And if we look at, let's go over here actually. Let's see. No, we don't want that. Upper air, we want upper air. I kind of forgot about this site. But we go 850 millibars, and you can see this is outdated. This is about 0Z. And so we have basically all the green areas are basically 70 to 90% relative humidity. The darkers are 90% humidity. Basically, these are where clouds are, So we have clouds. This is about 0Z, so about 5 hours ago from when I was recording this video. So it basically is cloud development, and you're also your temperatures overlaid over top of it. So you basically have your isotherms, you have your areas of cloudiness. This can be dictated by precipitation, So you look at this and you have clouds over here, and what's going to happen is that we're going to like look at this later, but it's going to be moving in, and then we're going to have warm advection come in, and we're going to have some warm advection induce precipitation, as well as we have some DPVA, so you will get precipitation. And if you don't know what I'm saying with DPVA, warm advection, you know, I'm going to try and make it a little more clear on this next map. That's what I'm going to try and do. And let's see, 500 millibar vorticity. We zoom in. Oh, beautiful. I love vorticity so much. And what happens is that we have a shortwave trough. I'm going to zoom out here because it's much easier seeing the bigger scope. Let's see about this. It's a synoptic storm. So it's much easier seeing a larger scale what's happening. So basically what we have is we have a shortwave trough over Kansas coming in, and we're on the downstream side of it. You see all this noisiness in the vorticity field. That's ageostrophic vorticity, which is basically a resultant of precipitation. So if you see the signature, there's going to be probably precipitation with it. Now what happens is that we get this shortwave trough to move into our area, and what we get is we get warm air advection. You can see the wind blowing from southwest to northeast here. And you can also see is that we have DPVA, which is, you know, this, you know, you got vorticity shade here, but basically, you know, you look at PVA and DPVA, so basically positive vorticity, which is the shade stuff, moving into an area with less vorticity, which is what's happening. So we're creating lift in the atmosphere. You get lift, you get moisture, and you get precipitation. And if it's cold enough, which it will be, you'll get snow. So, you know, I'm not going to look at snow maps because that's normally what I do. That's normally what I did back then. Back in the day, I posted a lot more snow maps, and I don't do that anymore. I kind of still look at them, just see, you know, like kind of laugh at them and stuff like that. But, you know, this is basically, you know, what I'm doing. I'm going to be showing vorticity because it's a great way to understand where the precipitation is going to break out without looking at QPF field. Without looking at it, just gig scope. You know, great tactic to learn is to look at a 500 millibar vorticity field and know what's going to happen. You know, like, oh, I see a shortwave trough right here. I see that we're downstream of it. I see a geostrophic vorticity, and I also saw that we have moisture with it. So then what's going to happen is we're going to get precipitation. And you saw with the surface observations and possibly with modeled temperatures, you'll see it's cold enough for snow, and you can make a forecast off snow. You know, and you can also look at soundings. Soundings are amazing for, like, you know, analyzing snowfall forecasts. You know, are we going to get higher ratios, lower ratios? Is it going to be totally saturated? We're going to get the dry slot? You know, where's the omega? Where's the lift? It's just a great way to learn how to forecast snow, you know? It's great. You just can't look at these forecast snowfall maps. They're pretty and all, but you don't get anything out of it. You don't know what's going on to produce it. If you get more of the understanding of what's producing it, you'll understand. You'll make a better forecast. There it is. You know. So yeah, guys. If you guys haven't followed me on Twitter, I'm at WX_Geek. And if you guys want to follow me, I'll just post like forecast thoughts. And if I'm busy, I won't be able to because I got school. I'm a meteorology student at the University of Illinois. So, yeah, I mean, that's it, guys. Hopefully you guys enjoyed this video, and hopefully you guys gained some knowledge out of this. And I'm basically planning on making storm chasing videos, you know, chases from my trips, you know. If there's like a tornado that I get, I'll post a video to here. Forecast updates, you know, about snow, severe weather, flooding, all that stuff, you know. So, yeah. I hope you guys enjoyed this video, and I'll see you guys in the next video.